In this video, we will be talking about systems of linear equations in two variables. To start, we need to talk about what a system of linear equations is, and what the goal of solving a system of linear equations is. If we have two lines in the xy coordinate plane, let's call the first line y equals 5x plus 6, and the second line y equals negative 2x minus 1. Each of these are linear because all of the variables are raised to the first power. If we were to graph each of these lines, well, the first line has a slope of 5 and a y-intercept of 6, so that line, something like that. The second line has a y-intercept of negative 1, slope of negative 2, so that line, I don't know, approximately is going to look something like this. Now, these two equations make up what is called a system of equations. And the goal of a system of equations is to discover where the intersection point is. Now, the solution to this system is negative 1, 1. That's the coordinates of this point. Now, clearly, this graph is not 100% accurate. But in this video, we're going to talk about how we can find this intersecting point. And so the intersecting point is the solution to the system. So what we see here is that this particular system has a single solution. So this system, let's write it like this. This system has one solution because there is a single intersecting point. If lines are parallel, we would have no solution. So if a system has no solution, that means parallel lines. So what we would have is the two linear equations would be parallel. Another way of talking about that would be the two lines have the exact same slope. So if the two lines have the same slope, those lines are parallel. They don't intersect, so we would have no solution. So that's one option. Well, first we could have one solution, we could have no solution, and then the third option is infinitely many solutions. And this is just when both equations are the exact same. So we would say both equations represent the same line. So this is the third option, infinitely many solutions. In practice, what we are going to see most of the time is a single solution, but it's good to be aware that we could have no solution or infinitely many solutions. Now, there are three main types of ways that we could solve a system of equations. We could solve it graphically, we could solve it by substitution, or we could solve it by what's called elimination. So these are methods for solving systems of equations. And it's advantageous to use one method versus another depending on how the system looks. I will say that solving a system graphically is probably the least desirable method, just because it's hard to be 100% accurate when we're graphing two lines to see precisely where those lines intersect. Now in this video, because of that, I will just talk about substitution and elimination. But to be clear, any of these methods will work in any situation. However, sometimes it's a little more obvious to use one versus the other. So let's look at an example here. We have 2x plus 3y equals 21, 3x minus 4y equals 23. I'm going to solve this with the elimination method. And the reason is because if we look at all of the coefficients on the variables, well, on this x we have a 2, we have 3y, 3x, negative 4y. what we notice is that all of the variables, or rather all the coefficients, are something other than 1. So because of this, we're going to use the elimination method, and we'll see how this contrasts with the substitution method. So what we do is we want to get either the coefficients on the x, right now we have 2 and 3, or the coefficients on the y variables, we have 3 and -4. We want those to be opposites of each other. So we would want one to be positive and one to be negative, but the same number otherwise. So what we do is we we manipulate some of the equations, either just one equation or both equations, so that we can achieve opposite coefficients. So what we do is, let's suppose I want to eliminate the x's. So I'm going to eliminate the x's. It doesn't matter which variable we try to eliminate. So what we do is, in this first equation, I need to get an opposite coefficient on the x as what I have in the second equation. So what I'm going to do is, in the first equation, I'm going to multiply each term by -3. Doing so will give us -6x minus 9y equals -63. And then in the second equation, I'm going to multiply by +2. And doing so, I'm going to get +6x minus 8y equals 46. So what we see is that the coefficient on the x variables are opposite of one another. Now when we add these equations together, the x's cancel. We're going to get -17y is equal to -17. Now we just have one equation with a single variable, and we can solve that just by dividing by -17. We get y is equal to 1 here. And then at this point, what we do is we take the value of y and we substitute that back into either of our original equations, and then we solve for x. So I'll substitute this into the first equation. We're going to have 2x plus 3 times 1 equals 21, and then we just solve this for x. 18, x is going to equal 9. So the solution to this system, we would say, is 9, 1. We write this as an ordered pair because this is the intersection point of these two lines. In this next example, I'm going to use the substitution method, and kind of on the flip side of when we want to use the elimination method, well, we would use the substitution method if one of the coefficients on any of the variables is equal to 1. And we have right here on y in the second equation is a coefficient of 1. So what we're going to do is we're going to solve this second equation for y. So if I add 2x to both sides here, we get y is equal to 9 plus 2x. And then what we do is, because we have one of the variables solved for, we're going to substitute what that variable is equal to into the other equation for y. So what we do is take that first equation, 4x minus 10, and then in place of y I'm going to substitute 9 plus 2x. So now we have a single equation with just one variable, so we are able to solve this for the variable. So 4x minus 90 minus 20x is equal to 6. Negative 90 minus 16x is equal to 6. Add 90 to both sides, we get negative 16x is equal to 96. Divided by negative 16x is going to equal -6 here. Alright, and then just like in the elimination method, once we solve for one variable, we substitute that into either of the equations. Again, it doesn't matter which equation we use. I'll use the second equation this time. So we would say -2 times -6. This -6 just gets substituted in to this equation. Plus y is equal to 9. So now solve for y. We have 12 plus y is equal to 9. Y is equal to -3. So our solution here is going to be -6 comma -3. So that is the intersecting point of these two lines. Okay, in this example, in the notes it just says to solve by any method. Now it doesn't matter which method we choose, because none of the variables are 1 or -1, I'm not going to use the substitution method. If we wanted to use the substitution method, let's see how that would work. And you'll see why this maybe isn't the best. So I'm going to take this first equation and I'm going to solve, I don't know, solve for x, I guess. So we have 3x minus 2y is equal to 1. We're going to have 3x equals 1 plus 2y, and then we have to divide by 3 here. So x is equal to 1 plus 2y over 3. So what we would do is we would take this value for x, we're going to substitute it in right here. So doing so, we're going to have -7 times 1 plus 2y over 3 plus 3y is equal to 1. Now we can solve this equation. This is something that we are capable of doing. However, it's a fraction. It's not going to be it's not super clean at this point. So using the substitution method, while it will work, the idea is that there's probably more areas that we could make a mistake working with fractions. So instead of this, I'm going to use the elimination method. So with the elimination method, we want to get opposite coefficients. I'll eliminate the x's here. So between 3 and -7, I need those to be opposites of each other. A common multiple would be 21, so I want one coefficient on x to be 21, one to be -21. So if we multiply the first equation by 7, we're going to get 21x minus 14y is equal to 7. The second equation will be -21x plus 9y is equal to 3. We have opposite coefficients on x. So when we add, the x's cancel. We get -5y is equal to 10. So y is going to equal -2. And then from there, we're going to substitute that into either equation. I'll substitute it into the second equation this time. So this -2 is going to go in here for y. We get -7x plus 3 times -2 is equal to 1. -7x minus 6 equals 1. We're going to get x is equal to, made a small mistake, this should be +7 here. So x is going to equal -1. So writing this solution as an ordered pair, we're going to say the solution is -1 comma -2. In other words, this is the intersecting point of these two lines. One last example here. This says, last year Mrs. Rogers invested $40,000. Part was invested at 6% interest per year, and the rest was invested in a risky venture at 10% per year. Combined income for the year totaled $3,120. How much did she invest at each rate? So we're looking for two different values ultimately. We want to know how much was invested at 6%. So this is amount, let's say x is the amount at 6%, and let's say that y is the amount at 10%. So because there's two variables, we must have at least two equations to solve for each of these variables. Now, what it says is part of the money, so $40,000, part of this was invested at 6%, part was invested at 10%. So together that adds up to $40,000. So one equation we're going to have is x plus y is equal to $40,000. And then it says combined income for the year totaled $3,120. So what's happening is two values are getting added together, and that's going to add up to 3,120. Now, what's to add up to 3,120, what needs to happen is, well, whatever amount was earned at the 6% interest plus whatever amount was earned at the 10% interest. So how we could write this is 6%, let's do it over here on the side, 6% of some amount, and the amount that is invested at 6% is X, plus 10% of whatever amount was invested at the Y amount, and that is going to add together to equal $3,120. So how we write percentages in algebra, we write them as decimals. So this is going to be 0.06 times X plus 0.10 times Y, and that will add up to the $3,120. So what we have here is a system of equations. We have two linear equations, two unknowns, so we can use either the elimination method or the substitution method to solve for X and Y. The first thing I'm going to do is, in this second equation, I'm going to multiply through by 10, and that will remove all these decimals. So this is going to give us 0.06 times, or rather, let's multiply by 100. We want to move the decimal 2 spaces. So we would get 6x plus 10y is equal to 3120 and then add 2 zeros, so $312,000. Then I'm just going to write the first equation right below, so everything is lined up. Okay, in the second equation, we have both variables with a 1 as its coefficient. So I'm going to use this substitution method here. What we can see is that if I solve this second equation for x, we would have x is equal to 40,000 minus y. And then what I'm going to do is I'm going to take this value of x, I'm going to take that and substitute it into the first equation. So we're going to have 6 times 40,000 minus y plus 10y is equal to $312,000. And then from there we just need to solve for y. And doing so, we end up with a y value of $18,000. So what this means is $18,000 was the amount that was invested at 10%. And then to solve for the amount that was invested at 6%, well, if we just think back to our first equation, we know that x plus y is equal to $40,000. So this would tell us that x is 40,000 minus 18,000, which would be 22,000. So in answering the question, we would say, in answering this question, how much did she invest at each rate? We would say Mrs. Rogers invested $18,000 at 10% and $22,000 at 6%. And that would be our solution.